Hello everyone, happy to see you here. Welcome back to my channel. Today we have a great equation n cubed minus n squared equal to 18. We need to solve this equation for n, so if you have your answer, if you're interested in that, you can also write a solution in the comments below and then we will check our answer, so it will be really interesting. So let's start. First of all, let's write this 18 on the left side. So this is our first step, so let's start with that. So we have n cubed minus n squared and minus 18 equal to 0. Okay, really great. What are we going to do next? My quick recommendation, a lot of students might be asking, why do you choose this expression? Because what I want to do, I would just want to express this 18 as 27 minus 9. And a lot of students might be asking, why do you choose this expression? Let's see, okay? So first of all, instead of this 18, let's write 27 minus 9. Okay, n cubed minus n squared. And minus, instead of this 18, let's write 27 minus 9. 27 minus 9. And final step, let's open parentheses. We have a negative sign, so that's why we need to choose this sign to the opposite one. So we have n cubed minus n squared minus 27 and plus 9. Of course, we can do this instantly without these two lines right here, but I just want to solve this question step by step. Maybe a lot of students here, so that's why I do this step by step. And of course, let's continue. First of all, why do you choose 27 and 9? Why do this constant are really great for us? Because 27 can be written as 3 cubed. Yeah, 27 can be written as 3 cubed, and 9 can be written as 3 square. 3 square. And a lot of students might be thinking, why 27 and 9? And this is my answer. Right here we have cube, right here we have square, and right here we can express this as cube and square. A lot of students might be thinking, okay, maybe let's choose 20 minus 2, for example. You can't express this 20 and in terms of squares, and you can express this 2. And of course, there are a lot of combinations. But these are the best for us. So cube and square. And right now, let's do this. Instead of this 27, let's write 3 cubed, n cubed minus n squared, minus, instead of this 27, let's write 3 cubed, and instead of this 9, let's write 3 squared. So plus 3 squared equal to 0. Really great. And right now, why do I choose this expression? Why do I expand it? Why do I express this 18 like that? Because right now we can group this cube with this cube and this square with this square. So right now, let's do this. Let's see how does it work. First of all, let's group our cubes. So we have n cubed minus 3 cubed, n cubed minus 3 cubed. Okay, we group these cubes together, and we need to group our squares. So we have a negative sign, and in parentheses we have n squared minus 3 squared. So n squared minus 3 squared. Okay, so I really hope you understand my solution until this moment. These are not the hard steps, but we express this, we group something, so I really hope you understand it. What we're gonna do next? Right here, we just need to look at this question from a different angle, because we have two parentheses. What do we have right here? We have difference of cubes. What do we have right here? We have difference of squares. So maybe you know this formula from school, but in case maybe you don't know this formula, I just wanna remember you. I just wanna learn this formula with you. So a cubed minus b cubed. This is a difference of cubes, so we can expand it in terms of our algebra knowledge. So a minus b. And we have in another parenthesis a square plus ab and plus b square. Really great. And right now, another formula, difference of squares. And a lot of students should know this formula. Maybe from my perspective, this is like the most popular formula for students. So that's why we write this one, a square minus b square. Everyone knows about it, and I really hope if you know this formula. So a minus b, a plus b. And right now we know everything. We know how can we expand this difference of cubes in terms of this formula, and we know how can we expand difference of squares in terms of this formula. Okay, really great. And right now let's do it. First of all, let's start with difference of cubes right here on the left side. So we have n minus 3, and in parentheses we have n squared plus 3n and plus 9. Really great. So we expand this expression in terms of this formula. And the next thing, minus, and this one, difference of squares, so n minus 3, n plus 3, n minus 3, and plus 3. So I really hope you understand it. If you have problems with it, I just recommend you to practice these two formulas. You don't need to learn this question, but practice these two formulas. Equal to equal to 0. Okay, we have this line, this expression. Right now, let's look at this question from a different perspective. We have, for parentheses, we have a long and complicated expression, but we have one common thing. We have n minus 3 right here, and we have n minus 3 right here. So basically, we can factor it. Let's do it right now. Okay, so we have n minus 3, n minus 3. And in another parenthesis, what do we have? We still have this expression, and we still have n plus 3. So we have n squared plus 3n and plus 9, and minus this one, and plus 3n plus 3. Okay, equal to 0. So we can't simplify this n minus 3. We don't need to do it. And right now, let's simplify this expression. So we have n minus 3 from the beginning, so n minus 3. But this one, we can actually get rid of this parenthesis right here because we have all the time positive signs. Right here we have positive. So let's we can actually get rid of this parenthesis. So n squared plus 3n and plus 9. What about this parenthesis? We need to change this plus to the negative sign because we have a negative before parenthesis. So we have minus n minus 3. Equal to 0. And the final step, let's add what do we have? Let's add the common thing with the n. We can easily do this, 3n minus n, and we have a constant 9 minus 3. So let's gather all these things together, and we have n minus 3 at this place, and right here we have n squared, 3n minus n, so plus 2n, 9 minus 3, we have 6, so plus 2n and plus 6 equal to 0. Really great. And right now, let's look at this question from a different angle once more. What do we have? We have a product of two parentheses, and we know from school, these are our basic school knowledge, when we have a product of two parentheses, and of course this product of two parentheses equal to 0, it means that the first parenthesis is equal to 0, so n minus 3 is equal to 0, or the second parenthesis is equal to 0. So we have n squared plus 2n and plus 6 is equal to 0. So we have two branches, first equation and the second equation, quadratic and linear equation. First of all, let's solve this linear equation instantly, because from here our n first equal to 3 without any problems. From here n first equal to 3. What about this quadratic equation? There are a lot of ways how can we solve it, but I'm going to show you this one. Maybe a lot of students here who have problems with the quadratic equation, so that's why I choose basic method of coefficients. So a equal to 1, b equal to 2, and c equal to 6. Our coefficients, let's start with the discriminant. So discriminant equal to b squared minus 4ac, and let's plug in each of these elements into this spot. So we have b squared 2 squared minus 4 times a times 1 and times c times 6. And I just see that our discriminant is negative, but let's check it. So we have 4 minus 24. Yeah, our discriminant is equal to minus 20. So that's why we can see it clearly that our discriminant is negative, less than 0. So in terms of school knowledge, of course, maybe you're in 5th or 6th grade, you have problems with the complex number. I'm not sure what you learn exactly, but in terms of school knowledge, a lot of teachers might be saying, okay, square root of our discriminant is equal to minus 20. So that's why right here we don't have roots, so you don't have to solve this equation. But we're interested in every root, so that's why we just need to solve this equation. We just need to solve this quadratic equation we need to find our root. So that's why when discriminant is negative, it means that in this branch we have two complex roots. Okay, two complex roots. And right now let's find our root. Let's plug in this minus 20 into this spot. So we have n second and third equal to minus b plus minus square root of discriminant and all over to a. Okay, and right now let's plug in each of these elements into this spot. So minus b minus 2 plus minus square root of discriminant square root of minus 20 and all over 2 times a, 2 times 1 equal to, okay, what can we do with this square root of minus 20? We can express this as 4 times 5 times minus 1. Okay, so we have minus 2 plus minus square root of 4 times 5 and times minus 1. Why do you choose this expression, not like 2 times 10 or 20 times 1? This is a great expression because then we can find square root of 4. Yeah, so over 2, okay, equal to minus 2 plus minus. Right here we can easily split everything right here, because when we have square root of a times b, you can write it as square root of a times square root of b. So we have square root of 4 times square root of 5 times square root of minus 1, yeah, and we divide it by 2. And right now square root of 4 equal to 2, square root of minus 1 equal to I, this is our complex unit, this is our imaginary unit, and let's write everything. So we have minus 2 plus minus 2i square root of 5, 2i square root of 5, and we divided by 2. And the final step, a lot of teachers prefer like splitting this expression by real part and imaginary part. So that's why maybe you're interested in this. Of course, it can be your answer, but in case maybe you have problems with it, so you can easily divide our numerator by parts by 2. So we have minus 2 over 2 plus 2i square root of 5 over 2. And that's why we're going to cancel these two, these two, these two, and these two, and our final answer. Minus 1 from here, from the beginning, minus 1, plus minus I square root of 5. Yeah, I square root of 5. This is our answer to this question. So n first equal to 3. So let's gather all these roots together. For example, right here. So our answer on the right side. So n first equal to 3, n first equal to 3, and second is equal to, really, let's go with the positive sign, for example, minus 1 plus I square root of 5, minus 1 plus I square root of 5, and third equal to minus 1 minus I square root of 5. And of course you can easily see that because of this imaginary unit, these two roots are, so right here we have two complex roots, and this one is real number, and this one is real number root. Yeah, we have n equal to 3. And finally, let's check real quick our root. Let's do this right here. So our proof, we have n cubed minus n squared equal to 18. Okay, so let's check this n equal to 3. So for n equal to 3, we have a great expression because we have 3 cubed minus 3 squared equal to 18. So everything is great right here because we have 27 minus 9 is equal to 18. So our root is absolutely correct. And right now, few thoughts, few really quick hints. I would like to say it really briefly because a lot of students forget about it. First of all, the most common mistake right here that a lot of students try to solve this question by inspection. Okay, they might be thinking, okay, n cubed minus n squared equal to 18. Why can I just choose these basic options like 1, 2, and 3. N equal to 1, not good. So 1 minus 1, n equal to 2. So we have 2 cubed minus 2 squared. So we have not good, but when n equal to 3, we have a correct expression. So n equal to 3 is a correct answer. But there's like one really important moment, because according to a fundamental theorem of algebra, I'm going to say it really quick, like maybe for everyone, it means that whatever the power you have right here, whatever the highest power you have, it means that many roots you will have in your question. So for example, we have 3 as the highest power, so it means that 3 roots we have in total. And that's a quick proof, because we have 3 roots and not one root that you find by inspection method. Okay, you have 3 roots, you have 3 as the highest power, we have 3 roots in total. Of course, we don't know how many real number roots, how many complex roots, but instantly, for example, you see it in your exam, instantly you can find out how many roots we have in our question, because one root is not good. We have 3 roots, and yeah, this is a quick tip, because a lot of students might be thinking, oh, this is a very easy question, n equal to 3, but you forget about the second branch. In the second branch, we have quadratic equation, and only in this way, only in the method of factoring right here, only in that way we can find our full solution to this question. Yeah, because one root, this is not a full solution, and with this method of factoring, we find our 3 roots. So it was my quick tip and quick recommendation, because every time you have an equation, try to solve this question completely, try to think a little bit more, but try to think how can we solve this question completely and step by step. First of all, our equation 3 is the highest power, so it means 3 roots in total. Okay, so inspection method is not good. Only 4 for proof in the end is a good method, but I have to find out what method do I choose for this question. And this is our method. To be honest, this is not a hard question. Don't be scared about it. This is like a classic quadratic equation without any problems. We just have to know these two formulas. We just have to know these like tricky moments and basic factoring, basic addition, subtraction, and multiplication. So don't be scared about it. But if you have problems with this question, write your question in the comments below. It will be really interesting to read about it. So it was my solution. I really appreciate that you're here, that you're watching this video right now, and I want to say thank you for this. Thank you for watching, for supporting me. It's also really, it's a crucial moment. It's extremely important for me that I have your feedback, that someone watched this video, and of course I want to genuinely say thank you for everything. Thank you for be here. And yeah, it's extremely important for me, and I want to say a huge thank you for everything. So thank you for your time. Have a great day. See you in the next videos, and take care of yourself.